Hello students. In the previous class that I discussed about hardwired control. So in today's class that I am going to discuss microprogrammed control in detail. So this concept is also very important. So in the previous section, as we have seen how the control signals required inside the processor, that is how the control signals required inside the processor that can be generated using a control step counter and a decoder or encoder circuit. Now I'll discuss an alternative scheme called as a microprogrammed control, in which the control signals are generated by a program which is similar to machine language programs. Here first we introduce some common terms. So the first term is control word, that is CW. So control word is a word whose individual bits represent the various control signals, as it was shown in the previous sections. Here each of the control steps in the control sequence of an instruction defines a unique combination of ones and zeros in the control word. Here the control words correspond to the 7 steps, as you can see 7 steps here. So we have assumed that select y is represented by select 0 and select 4 is represented by select 1. That is, select y is equal to 0 and select 4 is equal to 1, something like that. Here a sequence of control words correspond to the control sequence of a machine instruction that will constitute the micro routine for that instruction, and the individual control words in this micro routine are referred as micro instructions. The micro routines for all the instructions in the instruction set of a computer that are stored in a special memory known as control store. The control unit that can generate the control signals for any instruction by sequentially reading the control words of the corresponding micro routine from the control store. So this will suggest that organizing the control unit, as it was shown in the next figure. So this figure illustrates the organization of the control unit. Here, to read the control word sequentially from the control store, a microprogram counter is used here. Microprogram counter, that is MUPC. So this is used to read the control words sequentially from the control store. Every time a new instruction is loaded into IR, then the output of block labeled, that is starting address generator, so this block, so the output of this block is loaded into MUPC. Here the MUPC is then automatically incremented by the clock and causing the successive micro instruction to be read from the control store. Hence the control signals are delivered to various parts of the processor in the correct sequence. One important function of the control unit cannot be implemented by the simple organization of this figure. This is the situation that arises when the control unit is required to check the status of the condition codes or external inputs to choose between alternate courses of action. In the case of hardwired control, this situation is handled by including the appropriate logic function and in the encoder circuitry. In microprogram control, an alternative approach is to use the conditional branch micro instructions. So in addition to the branch address, these micro instructions specify which of the external inputs, condition codes, or possibly bits of instruction register should be checked as a condition for branching to take place. Here the instruction, that is branch which is less than 0. So it may be implemented by a micro routine such as that which is shown in this figure. So this figure is to illustrate the instruction branch less than 0, how it is implemented by the micro routine, right? Here, after loading this instruction into IR, that is in instruction register, a branch micro instruction transfers the control to the corresponding micro routine, which is assumed to start at location 25 in the control store. Now consider the location 25 in the control store. So this address is the output of the starting address generator block, which was shown in this particular figure, that is starting address generator block. Here the micro instruction at location 25 test the n bit of the condition codes. So if this bit is equal to 0, then a branch takes place to the location 0 to fetch a new machine instruction. Otherwise, the micro instruction at location 26 is executed to put the branch target address into the register Z, as shown in one of the steps, that is in step 4. Here the micro instruction in the location 27 loads this address into the program counter. To support the micro program branching, the organization of control unit should be modified as it is shown in this particular figure. So this figure illustrates the organization of a control unit with some modification. This is to support the microprogram branching, right? Here the starting address generator block becomes the starting and branch address generator. So this block is modified here. Earlier it was starting address generator, now it becomes starting and branch address generator. So this block loads a new address into mu PC, means this block will load a new address into this microprogram PC, that is mu PC, when a micro instruction instruct it to do so. To allow the implementation of a conditional branch, inputs to this block consist of external inputs and the condition codes as well as the contents of instruction register. In this control unit, the mu PC is incremented every time a new micro instruction is fetched from the microprogram memory, except some situations like when a new instruction is loaded into the IR, the mu PC is loaded with the starting address of the micro routine for that instruction. And one more situation is when a branch micro instruction is encountered and the branch condition is satisfied, then the mu PC is loaded with the branch address. And one more situation is when an end micro instruction is encountered, then the mu PC is loaded with the address of the first control word in the micro routine for the instruction fetch cycle. So except these situations, in all other situations, mu PC is incremented every time a new micro instruction is fetched from microprogram memory. So this is all about microprogrammed control. So in the next class that I am going to discuss micro instructions. Thank you.